Hello everybody, I am Dr. Sachidanand Sen, working as Associate Professor in the Department of EEE School of Engineering, SR University. So we are continuing with the lectures on battery management system, and this will be our sixth lecture, and today we are going to cover cell balancing techniques. So what are the cell balancing technique and why it is required to enhance the life of the battery, that we are going to learn in this lecture. So introduction. So why do cells need balancing? So first of all, what is a battery pack? It is very crucial to understand. So a battery pack consists of multiple cells connected either in series back-to-back connections, and they are again aligned in parallel. To previous classes I have discussed that one, that series connection increases the overall voltage and parallel connection increases the current drawn. So hence the total rating can be increased. So multiple cells are connected in series and or parallel to achieve the required voltage and capacity. So ratings and voltage can be attained by this series and parallel connection. So for example, suppose an electric vehicle battery may have 96 cells in series. Similarly, there can be such 3 to 4 series connected these modules in parallel. Okay, these can be arranged after that in parallel. Okay, so that complete set will be called battery pack. So what is the problem with cell balancing? Why we are going for this kind of solution is that the problem is to no two cells, okay, as multiple cells are involved, no two cells are perfectly identical. So there are definitely some variations in them. So what can be the variations? Manufacturing tolerance, okay. Then internal resistance can be differences, because all batteries are having different materials. Their slightly packaging is differentiated, or the operating temperature will be also different, aging rate will be different. So like no two person is having similar feature. Same way, each cell will be definitely having some fractional differences. Okay, so because of that only we are getting the problem with cell balancing, or that difference will be created. Okay, so all these things cause some cells to, what are the issues that we can face because of this marginalized differences? The charge, some of them will be charging faster, some of them will be charging slower. So reach voltage limits earlier, then some of them will be discharged at a different depth. Okay, so these are the problems that we can face. So over time, this leads to cell imbalancing. Okay, so what is the imbalancing? A situation where the voltage and state of charge of the cells in the same pack diverge. Okay, so the total voltage of individual cells will be different. Similarly, state of charge of individual cells will not be same for all the cells connected in a series pattern. Okay, so that difference is called the cell imbalancing. Okay. Now coming to this pictorial representation, here we can see, suppose we are having 3 cells, 1, 2 and 3. The before balancing, this is suppose one of the cell, and remember, cell is a single entity, single unit, okay, and battery will be having multiple cells connected in series and parallel manner. Okay, so suppose here 3 cells are there, just for representation. One of them is fully charged, state of charge is full. One of them is only 50% charged. Another one is, suppose say 80-85% it is suppose charged. Okay, so see the difference. It is still some scope of charging here. Still some scope is there, although less compared to this one, and it is for this one there is no scope for charging. Now so if we are still connecting it into the supply, so what will happen? This will become overcharged. By the time it will become fully charged, it will become overcharged and temperature will rise very sharply, and it can go into thermal runaway also. So similarly for this one also, for certain duration it will charge completely. After that it will again go for overcharging. So cell balancing is nothing but sharing this state of charge from one cell having more charge to another cell. Okay, so this pattern is called the cell balancing. Here what happens, we will transfer the charge from this maximum fully charged battery to this one. Similarly here, from here also something will come from here. So like that it will be balanced. So here you can see all of them are having same balance. Okay, passive balancing. So in passive balancing what happens, the surplus charged batteries will be discharged, okay, through some resistive medium. Okay, some resistance will be connected across that, and it will act as a load, and definitely some current will be flowing through the resistance, and the heat will be dissipated, and that somehow it will be, that is how it will be reduced. Okay, so here you can see this is, here is a reduction, here is a reduction, and here is a reduction. So here it was already at the same level. These two batteries need to be drained out. Those things we'll see in detail. Similarly, active cell balancing, what will happen? The charge from here will be passed or transferred to the battery with less charge. Okay, the battery with higher charge level will be transferred from this one to the less charged batteries or cells. Okay, so here wastage will not be there. You can see this bar, suppose this bar is coming over here. Okay, and so we will be having all at the same level, and wastage is not happening. Okay, so this is called active balancing, that we will see. These are the two types of cell balancing that we are going to learn. Classification is there. So what is the consequences of cell balancing, imbalancing? Okay, so one weak cell limits the overall pack performance. Like here we can see, suppose this battery was slow in charging. So because of this, what problem will happen? All others will also have to degrade their performance. Okay, it won't be able to, by the time it will fully charge, they will be overcharged. Okay, so that weak cell will limit the overall pack performance, because it's like a analogy that a chain, strength of a chain is equal to the strength of the weakest link. Similarly, strength of the battery, okay, total pack will be equals to the strength of the weakest cell. Okay, so the weakest cell will determine how the overall performance will be there. So a chain can be completely strong throughout, but if the one of the link is weak, so that weakest link will be the first one to crack or break. So that, like that, it will be the overall performance of the chain, or similarly that battery pack will be determined by the weakest cell. Okay, so risk of overcharging, as mentioned, some cells while others are undercharged, this will be a problem. Reduced total usable capability, so how much total electricity it can store, that will be determined by the state of charge of the battery which is least charged, complete means least charged. Okay, so potential thermal runways can happen, it can damage the cell. Thermal runway is like increasing the temperature, which will accelerate the further chemical reaction, and more ions will be generated, more and more current will be flowing, and that will how, and further temperature will be increased. So this cycle will continue, and ultimately it will damage the battery, and fire hazards, smoke will come, fire hazards can also, it can ignite the battery, it will, fire can catch. Okay, so reduced lifespan of the pack. So ultimately lifespan of the battery will be reduced. So here are the cell balancing techniques. If it is not used, already mentioned. So see here, initial status of suppose this one, in use when the battery is now discharging. Okay, usable remaining. Okay, mean because every battery is having some upper limit. Okay, charging limit and suppose lower discharging limit. So here you can see once this is charged, we can charge it up to this much extent. Here if we are charging up to this much, so still some scope is remaining and which is really unused. Okay, so that is the disadvantage. If we are following cell balancing, if we are using cell balancing, what will happen? All the cells will be have same level of state of charge. So if we want to charge it further, we can have that facility over here. So you can see usable power will be more in this case. It can be fully charged. So now come to the classification. Just now I have already given you the overview. Now we will see in somewhat more detail. That is passive cell balancing. So what happens in passive cell balancing? So it is simple and cost effective. Okay. When a cell reaches the full charge, excess energy, okay, excess energy is dissipated as heat using a resistor. So we are making a circuit where a resistor is acting as a load for the battery, and current will be start to flowing through that one, and because resistive nature is there, so it will increase the temperature, it will heat up and dissipate the heat. Surplus charge can be released in the form of heat energy. Okay. So basic principle is that a comparator circuit monitors the voltage when the cell's voltage is more than threshold. Some threshold level need to be set. Okay. So that a transistor switch or some SCR based switch will make the circuit or close the circuit, so that bypasses the charge via a resistor. So I bypass equals to I cell minus V target. Okay, so whatever is the cell voltage minus whatever is the voltage required. Okay, it is preset value. Okay, divided by the R bypass, whatever is the magnitude of the bypass resistor. Okay, so current will be determined by this formula, difference in the voltage, excess voltage minus the target voltage divided by the resistive path. So what are the pros for this one? Low cost. It is a low cost method. Simple control logics are used. Okay, then it is compact in size. Okay, the additional circuitry required for making the cell balancing is somewhat less. Okay, cons: energy wastage, generates heat, works only during charging. Okay, energy wastage will be there because we are dissipating the already charged part of the cells. Some of the cells will be wasting that one in the form of heat. So definitely energy waste is there. Heat generation is there means, so again it is a problem for the battery. Some thermal management system need to be in place. Okay, so that will otherwise create problem. So works on during charging. It works on during charging. Now cell. So this diagram shows that a resistor can be connected by closing a switch. So for this cell, a closed path is formed. So that this resistor will dissipate the heat. Here you can see it is closed, and current will be flowing definitely through this loop, and some heat will be dissipated. So similarly here, same thing is shown. Individually these switches can be controlled, or at a time it can be controlled in this manner through a proper controlling switch algorithm. Okay, this switch control. Okay, these switches can be individually turned on and off. So, and it will bring in the resistive element into the circuit. Then passive cell balancing, still we are continuing, and another feature is that by using, this is the cells, and RC, sometimes not only R, so sometimes RC can also be used. Okay, capacitor, of course after certain time this voltage will be equal to the cell voltage, and it will help to dissipate the heat, and some additional control circuit can be used, okay, as a switch. So cell balancing using bypass resistor, so charge shuntings. This is also showing some similar features like resistors, how it can be brought. And one more thing, we can enhance the magnitude if it is fixed, and by somehow we can connect more parallel, or we can create some more circuitry where additional resistors can be brought in. So that is switched resistor, like variable resistor. Okay, so that features can also be added into this one. But of course, cost will be more and circuit complexity will increase. So these things also need to be taken care of. Okay. Now coming to the second method of cell balancing, that is active cell balancing. So what happens in active cell balancing? So actively transfers the charge from higher voltage cells to the lower voltage. So here what happens? no wastage will be there. As I already mentioned, it's like one example we can give. A bucket, two buckets are there. Suppose one bucket is 80% filled, another bucket is 30 or 40% filled. So to make both the buckets same, either we can pour the water out of the bucket with which is 80% filled, so that water will be going wastage. Then we can bring them into the same level, like 40% of the bucket we can bring by removing or throwing away the 40% of the water, and from that 80%, and both will have the 40% of the water inside the bucket. But another way can be there, we can use a mug, okay, or a jug we can use. We can take out the water from the bucket with 80% level, okay, and we can put it inside the 40% of the bucket. So what happens, suppose we are removing 20% or we are shifting the 20% with the help of the mug from one bucket to another bucket. So after a while we will have 60% remaining here, and this bucket will have, second bucket will also move from the 40% to 60%. Okay, so 20% additional water will be transferred from one bucket to another bucket, or first bucket to the second bucket. So this analogy help us to know that there won't be any wastage. Okay, actively transfers the charge from higher voltage cells to lower voltage cells. So already mentioned, this is the most important advantage of active cell balancing, that there won't be any wastage, energy wastage in this mechanism. Okay, now come to the different methods by which we can use, like the mug. I discussed about a mug. So without mug it is not possible to transfer the water from one bucket to another. Okay, definitely that will also otherwise create some wastage. So the mechanisms that are available are capacitor based redistribution. Okay, a flying capacitor can be connected in between so that some charge can be transferred, because capacitor uses electrostatic principles to store the energy. Like a mug will store the water for a short duration and it will pour it into the second bucket. Same way the capacitor will extract the charge from the battery which is having a higher charge level. It will store it for a while and it will transfer it, or in fact it will be a continuous process, okay, transferring through a capacitor. So a flying capacitor shuttles charge between the cells. Okay, inductor based energy transfer via magnetic coupling. So another method is inductors based, or capacitive method. Inductor can also be a energy storage, so it uses electromagnetic principle. So energy transfers via magnetic coupling. Energy is stored in a magnetic field and transferred to the target cells with lesser amount of state of charge. So transformer based technique, isolated charge transfer. Okay, transformer based techniques are what happens, we can use some isolated transformers also. It will help to connect the two cells. Okay, it will help to connect the two cells. Okay, isolated circuits move energy between cells in parallel branches. Okay, so some form of additional circuitry can be made with the help of transformers to transfer the charge from this first cell with higher state of charge to second cell with lower state of charge. So this is the overall representation of cell balancing, especially active cell balancing. Here there won't be any wastage. Most of the charge that has been already stored in some of the cells will be redistributed to the other cells. Okay, so what are the advantages of this one? High efficiency. So efficiency will be definitely enhanced. Okay, energy conserving, so there won't be any wastage, means energy conservation is achieved. Then enhances battery life, so battery life will be improved. Okay, then cons means expensive. So definitely to use a mug you have to purchase that one. So similarly here, to build additional circuitry you need to have a capacitor storage device, so that will also be required to be integrated into the cells. Okay, so expensive, complex to implement, okay, requires switching hardware and logic. Okay, expensive, complex to implement, requires switching hardware and logic. So switching hardware and logic means definitely some hardware means capacitor is connected or inductor is connected, transformer is connected. So these are hardware components. So some switches need to be used to make and break the circuit. So that is how that switching will be taking place. So this is also a representation we can see here. This battery, suppose green cell is fully charged, then yellow is partially charged, and this is red is slightly lesser charged. So we are expecting all three to be at the same level. So what we will do, we will lose these two bars of the charge. Here one bar will be wasted in the resistance. Okay, so this is called the passive element. Whereas here same thing is there. We will be transferring this current through this converter, and this path will be filled so that this can be charged. The battery can be, this cell can be charged. Okay, so I3 is the charging current for this cell. So like this, active and passive cell balancings are implemented for the improving the performance of the weakest cell. Okay, so it's like in a chain, if the links which is having the strongest strength, they are able to support the weakest link. Okay, so that feature is although not possible for a hardware chain, but in cell we are able to install or initiate such kind of process, and that process itself is called balancing. Okay. Now coming to the total representation of the different topologies. So cell balancing broadly are having two types: passive cell balancing, active cell balancing. Okay, fixed shunting resistor. So in cell balancing passive type, what happens? Already mentioned, the resistors that we are connecting, which will be extracting the surplus charge in the form of heat by flowing the current. Some heat will be dissipated. So that resistor can be of fixed nature. Okay, so fixed shunting resistor is used, or switched shunting resistor is used. Okay, switched shunting resistor is used. And here switched means, remember, variable. Okay, we can add more resistors through some parallel connection, parallel switch, but of course complexity will increase. Now active cell balancing, already mentioned, inductor or transformer based is there. Then in transformer, different types of transformer, different types of inductors are there. Single inductor, coupled inductor can be connected, single transformer, multi-winding transformer, multiple transformers can be connected. But of course these are too complex to be implemented. Mostly active cell balancing are either converter based or capacitor based. Okay. So in capacitor based, what happens? Single switched capacitor can be there, multi switched capacitor can be connected. It's like connecting a resistor. Like in the capacitor can be one or multiple. Then converter based, so different types of converters can be used, like buck boost converters. Okay, quasi-resonant converters can be also there. Ramp converter is there. Full bridge converter is there. So different types of converters can be used to transfer the charge from the higher stored charge from the cells to the lower stored charge cells. Okay. Lastly, cell bypass. And what another active method is that those cells which are already charged, means up to a certain peak value, they can be bypassed. They should be removed from the circuit. Okay, and somehow we are able to provide the charge to the remaining ones. Although it is not that much easy to be implemented, but this is also one type of mechanism where we can bypass the cells which are already charged beyond 80 or 90%. So this diagram also depicts the similar classification and all. So cell balancing, passive type are fixed shunt, switch resistor shunt. Okay, active types are capacitive, inductive, transformer based, converter based. So single switched capacitors, double fired capacitor. Okay, so inductor, single, multi inductor, single transformer, single core, multi-core, so flyback, push-pull converter. So the different types of converters are there. Now coming to the algorithm. So what a basic algorithm will look like for to implement this state of charge balancing or cell balancing. There has to be some basic algorithm. So what is the algorithm? So we have to first of all continuously monitor the voltage and state of charge of the battery. And remember last lecture we have discussed that state of charge cannot be measured, it has to be estimated. So collect the voltage and current of the battery pack, estimate the state of charge for each cell. What is the state of charge for each cell need to be estimated. Then calculate the difference of state of charge between each cell, single battery. So what is the difference between different cells, difference in state of charge for different cells, that need to be obtained. Okay, so that state of charge, if it is more, then the set value, preset value, what will happen? This difference magnitude is more. If it is yes, so in group balancing will start. So then it will start balancing that one. Okay, that process. If it is no, it will be bypassed and it will calculate the state of charge difference for the neighboring branch. Okay, neighboring parallel connected cell group. Okay, so here again it's same threshold value. If it is more than the threshold value, the state of charge difference is more, then again it will start grouping that one, it will start balancing. So this is the basic process. Monitor the parameters, estimate the state of charge, calculate the find out the state of charge for individual cells, and once the state of charge difference is more, the difference is more means then the required value, then it will start the balancing. So see, if marginally difference is there, it won't impact that much. Like suppose it is 40%, it is 42, 45%. So small difference is there. But this gap, if it is 10% more or 20%, so that gap need to be balanced. Okay. So I think similar things are also depicted over here. Like it will start, enable. Okay, check the terminal voltage of parallel stand. If it is more like voltage based, if it is more than this one, close the switch to charge the supercapacitor. Okay, this is switch to supercapacitor based active cell balancing. Okay, so charge the supercapacitor, close the switch to discharge. Okay, if it is less, it will discharge. So these are some mechanisms or algorithms, flowcharts that can be used to apply the or implement the control design for the cell balancing. Okay. Now here now we'll see the control algorithm for balancing. So this section explores how and when to apply the balancing, whether passive or active balancing we are applying, what are the different methods through which we can implement these things. So common control techniques, like just now we have seen voltage based balancing. So what happens in voltage based balancing? So starts when voltage difference between highest and lowest cell is greater than the threshold. Like suppose a threshold can be 50 millivolt or 100 millivolt. So the difference in voltage will initiate the balancing process. Okay, so that is why it is called the voltage based cell balancing. Okay, voltage need to be monitored. Once the voltage difference between any two cells is more than a threshold, preset threshold value, then we will start the process of cell balancing. Okay, it is suitable for both passive and active schemes. Okay, until the threshold is crossed, there won't be any initiation of the balancing process. The cells will be charging as usual. Whenever the threshold is crossing, then only as per the algorithm something need to be transferred from using active schemes, or something need to be dissipated using passive schemes. So state of charge based balancing. So more precise as compared to voltage based and SOC based. So SOC based is having better features. Okay, so more precise than voltage based lithium ion chemistry, where voltage versus SOC is non-linear. Okay, requires accurate But here the disadvantage is it requires state of charge estimation, and that need to be accurately calculated. Okay, so between these two, state of charge is the more preferred one. Okay, more precise than voltage based lithium ion chemistry. Okay, now end of charge balancing. So balancing only occurs during the final stage of charging. Like in batteries, there are two modes of charging. Okay, constant current, that is the initial part, and beyond the 80% of the battery, once the battery is crossing the 80% of the state of charge, that constant voltage mode is initiated. So in that mode, we can do the balancing. Okay, so that is coming under end of charge balancing, reduces wear and energy usage. Okay, so frequently we are not turning on or turning off the switches. Okay, we are not connecting the resistors, we are not connecting the capacitors continuously. Once the battery are charged up to above 80%, then only we are initiating this process. So this is this type of control algorithm can be called as end of charge balancing. Okay, then real time dynamic balancing. So like already mentioned, either you have to wait till the end to do the balancing, or you can continuously monitor and do the rebalancing. Okay, continuous monitoring during the operation, charging and discharging, seen in advanced electric vehicles or aerospace systems. Okay, so only sophisticated vehicles or activities where we are relying that cells should be balanced continuously, it will be implemented, otherwise not. So what are the important factors while considering the cell balancing as is balancing speed. Okay, how fast energy can be redistributed or dissipated. Okay, how fast the energy can be redistributed or dissipated. Balancing period is like continuous, periodic or event triggered. Okay, so first one is balancing speed, which one will be faster to redistribute. Second one is balancing period, whether it is continuously balancing throughout the charging process, complete charging process, or it is charging or it is initiated periodically. Okay, for a certain duration it will be activated, then it will automatically turn off, then again after certain charging it will activate. So it can be either event based or duration based. Okay, time based or event based. Something, if something is happening, then if it is working, that we have means based upon certain event or activity. Okay, then balancing priority, when the balancing will be initiated. So large difference will be balanced fast. Okay, first we have to cover up the large difference in state of charge. Okay, so those cells where the difference is more, they need to be transferring the charge. Okay, so priority, if multiple cells are having the differences, so highest difference should be filled first, then sequentially it should be cycled. Okay, so this is all about the things that need to be taken care while implementing the cell balancing technique. So here balancing speed, balancing period and balancing priority are of consideration. Okay, then control strategies already mentioned can be of capacity based, state of charge based or voltage based. In capacity based means depending upon the ratings. Okay, rated capacity, available capacity, this part is suppose inactive. So it is the best method to improve the energy and power availability of the battery pack. Okay, computational cost is very high. So disadvantage is computational cost is very high. Whereas for state of charge based, it reflects cell inconsistencies in the better ways. Okay, it shows cells inconsistencies in a better way. It is more robust under dynamic operating condition. It will be more robust under dynamic operating condition. So computational complexity is again higher. Last one will be the voltage based, depending upon the difference in the voltages. It is a simple approach. Sampling of the cell voltage is straightforward. It is very simple to monitor the voltage because measurement is possible. The voltage is not accurately represented of state of charge. This is the disadvantage, because if we are following the voltage only, then the charge, state of charge, actual state of charge of the battery is unknown. Just we are relying upon the more voltage and we are transferring the state of charge without fully aware that because of the increased voltage, whether that state of charge is also more or not. Getting? So that features, that problem can be there. So inefficiencies will be there. So that this is the control strategies how we can implement, that is capacity based and state of charge based, okay, and voltage based. So in the last we will be just having a comparison and summary. So what happens? So let us compare the passive and active balancing, okay, in terms of technical trade-offs and application suitability. So first of all, energy efficiency. Okay, energy efficiency means passive balancing. Low energy efficiency is low, energy is dissipated, wasted in the form of heat, whereas active balancing, it is high, energy reused within the pack. No energy is wasted. Energy conservation principle is fully taken care of. Okay, we are not going for any wastage. So cost will be definitely, in passive we are using a simple resistor, also that is fine. So cost will be low here. And active balancing, the cost will be high, moderate to high. Circuit complexity is simple in case of passive balancing. In case of active balancing, it is complex. Switching plus logic is required, algorithms need to be developed. Okay, heat management requires heat sinks, because in passive what we are doing, we are dissipating the heat. So that heat dissipated will ultimately increase the ambient temperature. Okay, so some form of heat sinks, which will be like aluminum heat sinks are available, they will be used to dissipate the surplus heat. Minimal heat is required for active balancing. So applications where it is used, passive cell balancing means if the small cells are used, we can go for wastage. Okay, so small systems, example BMS for tools, some instruments are there for them, toys we can have. Okay, for active cell balancing, so sophisticated applications like electric vehicles, drones and aerospace. So in that type of devices where we are using batteries as the energy storage systems, okay, so then we will be definitely relying upon the active balancing. So this was all about the cell balancing. We have covered the topics like what is cell imbalance, why it happens, okay, because of the different features of the individual cells, that is definitely different from each other. Okay, then how balancing can be done, passive techniques, active techniques. Okay, what are the pros and cons of these things? Okay, classification and all, we have covered all the topics. So with this, we will stop this lecture, and in the next class, we will again meet. Thank you.